I'm Justin, and today I'll tell you something about taming the beast, Bazel, to work better in IntelliJ IDEA. Now, I have a vision of a world where editing and building your code is one integrated workflow. A bright new future where you need not think about how to configure your system to make it compile at all. A world in which code writes itself and we can finally take the time to express ourselves in art and get an artist's salary, or strike that last part. Now, actually, I'm just taking baby steps in this direction. I've been working on making build tools work better in the IDE, in IntelliJ, for over 7 years now at JetBrains. And, well, on the face of it, it seems quite simple. You know, you just write a bit of code to make the IDE talk to the build tool, like run a few commands, get the output, easy. Write a bit more code to get the tool to get the output from the tool. Let's say it used to be SBT that I worked on. Easy. Well, and then I found myself writing an SBT plugin that inserts a hidden character into the SBT shell so that IntelliJ can parse the beginning of an input prompt and then sideloading this plugin into the SBT config through custom plugin directories. So yeah, very easy. Now, why are we in this situation? Well, the build tools typically are not designed with the IDE in mind, nor was the IDE built with build tools in mind, historically at least. So the build tool is maybe a bit like this itsy bitsy spider crawling along a directed acyclic graph, eating some files, running little programs on them to turn them into other files, and then feeding them into the next node. It's all nice and algorithmic. Whereas the IDE ostensibly also uses algorithms, but it might seem like a bit more like this sorceress here trying to conjure up a piece of code, a file from somewhere. So basically random access across your code base, navigating back and forth, and you want to jump anywhere, do things, refactor the code without even being able to build it. So in a partially broken state. And all this implies that the IDE and the build tool need a partially different project model. And well, we used to define the project model in the IDE, directly in the IDE, and we still have some nice GUIs, graphical windows where you can define which files go in which module in IntelliJ, for instance. But I don't know, not many people seem to touch these anymore, at least I don't. I just sometimes check these windows out if there's any issue with what got imported from the build tool. So yeah, we call this import or refresh or reload or sync because we have to synchronize the project models. And usually these days we want to use the build tool as a source of truth. So yeah, ideally we want them to be the same. They cannot always be the same because they're built against different constraints. Also, parts of them in the build tool are often computed, so some build tools try to be declarative, but in the end they all end up having some kind of scripting either inside them or around them that modifies the project model or computes the project model, because you don't really want to declare repetitive things over and over again. So that means you have to run the build tool to actually know the whole project model. So yeah, keeping things in sync is hard. So some years ago, we came up, that's JetBrains and the Scala Center, with this little protocol that I've spoken about here previously some years ago, called BSP, the Build Server Protocol, to solve, or well, at least mitigate this issue of talking to build tools, so I wouldn't have to sideload plugins into SBT or any other build tool ever again. And well, and as a side effect, maybe solve the N by N problem of integrating N build tools with N editors or IDEs. Well, I only really care about one of those IDEs, but other contributors cared about others, so we actually kind of agreed on this protocol. As the name implies, it kind of is inspired by and complements LSP, the language server protocol, if you know that. But it aims to integrate build tools and the IDE. And it does this by abstracting the project model into a few generic concepts, such as targets, dependencies between targets, sources, and offers a few standard requests for building, testing, running, and very importantly, signaling errors and messages and progress that happen on the build tool side. So this has been quite successful in the Scala world. At least all the major build tools there support it. It was also kind of inspired by, in Scala back then, every few months or so somebody came up with a new build tool, which was kind of troublesome to integrate. Well, meanwhile, I've moved on a bit because recognize this new challenger, this beast called Bazel appearing on the horizon, falling over the Bay Area and everywhere else, consuming big monorepositories. So what attracted this beast? Here's the list: large complex code bases, projects just always grow. And these large code bases predictably lead to long build times. Even if you have small changes, you might complain over build times over half an hour, hours, days. And as your organization and project grows, people bring in their favorite language, so you build in against multiple language ecosystems. And well, now, if you try to reduce those build times, one approach you might take is just splitting everything up into smaller repositories. But then you land in dependency hell, depicted here, where you have to, if you change one important library, then you have to update all dependencies or all dependents of that library to bump the version and probably be synchronous ideally, and then update all their dependencies and so on and so on, and you spent a week just updating dependencies. So the popular approach these days is to throw everything into monorepos, just have one version of everything, so no more dependency hell. But, well, you have new problems. So you need to be able to build all the languages in there, and you ideally want to do it incrementally. So making the deal with this devil, wait, what do you get? It promises to be fast, achieves this by aggressive caching, promises to be correct, whatever that means. But generally it means that builds are reproducible and hermetic, so independent of what system it runs on. So ideally, if you run it locally or on the CI, you'll get bit by bit the same result. the cost of this is, of course, you have to pay if you make a deal with the devils. You have to fully specify all your inputs, not just the source files and their exact versions, but also timestamps, environment variables, I don't know what else. Bazel is generally built to respect all these, and, well, if you change one of them, it might cause a complete rebuild. So you have to watch out a lot. And this also means you can't rely on system-level tools or libraries, so stuff you have installed in your computer. It has to be defined as part of the build. But the real crux, as I've heard, has been the IDE experience. So I've talked to a lot of customers over the past year, and yeah, over and over they say again their experience with Bazel is lacking. So, well, we have this nice protocol, BSP. We have a client that was implemented in the Scala plugin. So just write a BSP server, right? So it should be easy. Wrong. Well, we did write a BSP server. It wasn't too hard. It took like a few weeks. And it worked well enough for one project that was Bazel BSP. And the next project we tried it on, well, it broke, of course. And every other project, additional project we try, we find additional problems that we have to solve, like one by one. So this has been quite challenging because there's always something breaking. But after a lot of work, well, we built a new BSP plugin for IntelliJ. It's currently in open, hidden beta. Ask me about it. Anyway, now most JVM projects, Java, Kotlin, Scala, work with it, and some Python projects too. So yeah. Now, yeah, I said JVM works. We still have the challenge that any larger user may be inclined to write new Bazel rules. So the configuration is very flexible. There are like standard rules, sets of rules that, or plugins you could call them, for Bazel to build individual languages, but sometimes there are multiple such rules because somebody had a different idea of how to do it, and we might need to integrate with them separately. So for each set of rules, we have to write a new integration, both for getting it from Bazel and for importing it into IntelliJ. So for each language, there are special considerations. So that makes Bazel kind of uniquely challenging to tame and integrate. I'll just tell you about some of my favorite problems we encountered. One of them we call the single file source roots. So Bazel is nice and flexible and general, so you can attach to a target a bunch of sources. You attach them either as individual files or as a set of files defined as globs, which then get expanded to a regular set of files. If you talk to Bazel now, you will only get this set of files. It expands them for you. It doesn't even tell you the globs unless you parse the configuration files directly. Whereas in IntelliJ, historically at least, it doesn't support individual files as sources in modules. It always works on a directory level. It was just more comfortable, more simpler to implement, I guess, and worked fine with Maven, with Gradle, to some extent with SBT. With Bazel, not so much. So you have sometimes issues that, yeah, the mapping between sources and modules doesn't work correctly, and packages, so Java packages can be split between multiple Bazel targets, whereas in IntelliJ we assume, at least historically, a one-to-one mapping. So we went on an odyssey to cure the symptoms. At first we tried it, doing it the right way, like actually patching the platform to accept files, because, well, we've been working on a new project model in IntelliJ for several years now in the background, and it can cover some of the use cases, like adding single files as sources to a module. But they were filtered out because none of the language plugins really supported this, so it broke the language plugins. So we tried to fix this, but then we found the language plugins rely quite heavily on, especially the Java plugin, on this implicit bidirectional map between package and package directory, so one-to-one mapping. Now, we tried removing that, but it turns out that that has performance implications, and the last thing you want in your IDE is performance problems. So we found a new workaround. Classic hacks, registering a dummy directory on the top of a package root. Yeah. Anyway, the result of this is, if you use Bazel with IntelliJ, you probably want to just define your sources, put your sources in a very standard directory structure. You're probably familiar with it. Just have each directory correspond to a package segment. So this is the standard Maven layout, or standard Java layout, really. So even if Bazel allows you to circumvent this, try not to. It will just work much smoother. Okay, another favorite problem of mine is the shared sources problem. Well, in Bazel, this is a common pattern, or also in SBT. In Maven, maybe not so much. Basically, the idea is you have targets or modules that compile the same sources in different contexts. So, for instance, you want to compile a source against both JS, JVM, or native, or against Scala version 2.12, 2.13, 3.0, because you want to release your library to different Scala versions, for instance. Yeah, this works fine in SBT, in Bazel, but IntelliJ also has yet another long-standing assumption that you have a one-to-one mapping between modules and source directories. What this means in practice, then, if you have multiple contexts in the same module, you might get completions that are not supposed to be there, or alternatively, if you don't import them fully, you might get red code where it shouldn't be. I can maybe show you an example soon, if we have a few minutes. Now, what do we have what do we do if we have a bunch of layers and problems mediating between these layers? Well, we add another layer. We call this the magic meta model. It's just an implementation detail of our BSP plugin. And basically, it's a project model that's between BSP and IntelliJ workspace model. So now we have 4 models that we need to keep track of. And, well, this one keeps is fairly simple. It just keeps track of which targets depend on which sources and allows you to switch on the fly between sets of sources or sets of dependencies. Now, these were my favorite problems. They're not the only ones. So day to day, a big part of my work these days is just talking to customers, understanding their requirements and blockers, and talking to various interface points, so the authors of Bazel at Google or rules authors at various orgs. So each one has their own interest, languages they support, if they're not supported by Bazel itself. The IntelliJ platform teams and the individual language plugin teams. And so, yeah, basically these technical problems become organizational and political. And that's just in this small niche of build tool integration with IDEs. Yeah. So we talk to contribute on all these fronts. Now, so here the beast has maybe been tamed a little bit. Any questions so far? If not, yes?
What you're talking about is different from the Bazel plugin for IntelliJ.
Oh yes, I didn't even mention that one. So yeah, there's the Bazel plugin for IntelliJ, which was created by Google. Unfortunately, yeah, nobody was really happy with it. But we are actually co-maintaining it until this new plugin is sufficiently mature. Yeah. Yes?
What are people doing in the meantime? Like, are they just using that plugin? Or
Yeah, pretty much.
VS Code or what?
Yeah, or that. So if you want Bazel with IntelliJ right now, most of the time you want to use the Google plugin. I think for JVM, our plugin will be ready quite soon, in the next month or two, at least for some use cases. Yeah. Anyone else? Yes?
Might be a silly question, but do you have any stats on test times compared to something like SBT?
Not off the top of my head. Like time it takes to execute tests in Bazel. Yeah, I don't have stats at hand, but the main benefit is with Bazel, yeah, it will cache test outputs based on the inputs, so you can avoid rerunning tests or building parts in many cases. With caveats, like depending on how you configure your build, sometimes the incremental build times may be longer than with SBT. Bazel still depends a lot on manual configuration or configuration through additional tools that write the build files for you, so that define the build structure for you. But when you have that, you can get pretty fast incremental rebuild and test times. Yeah?
Is there any like nice migration guides for like, hey, you have a big SBT project to Bazel, like this, if I come back to my team and say, hey, I heard this talk, I want to use Bazel, it's going to be a challenge, whereas if I was able to maybe do it on the side and go, hey, look, or you know.
I don't have any in my mind right now. Well, I think, Liha, you wrote something about that some years ago, but I don't know right now. Any more? Okay, how much time do we have?
Another few minutes.
Another few minutes? Okay, so I'll just give a very short intro into the new plugin. Let's see. So I prepared an example project so that it won't take forever to load, and of course it jumps. So I just open this project very straightforwardly. And, well, this is very uncomfortable to do on a double screen. Okay. Do you even hear me? I hope you hear me. So I open this project. You see a standard project structure. You'll see here there is a sink with a bunch of steps. And you'll have this little Bazel icon here on the right. A list of targets that are defined. So I only have a handful of targets, but it can be thousands in many Bazel projects. And, well, you can say double click this one to compile it. You also have many other things you can do, like build, copy target ID. Or in this one, you can also run it. And it runs the main in that target. So it gets the information from this from Bazel. So basically, the things you'd expect from a build tool integration. What we have, maybe I will just switch the. I want to mirror the displays instead of. Mirroring button. Here we go. That's slightly better. Okay, so this project also shows you the issue with shared sources. So let's have a look. So here's what a Bazel build file looks like. And basically this just defines it as a Java library with a glob of sources. They're just the ones in the same directory as this build file. And a dependency on libb, libb1. So the specialty here is it defines two targets within the same Bazel package, which is a concept that is related but different from the Java package. And you have, lib_a1 target and lib_a2 target, and they are both have the same sources in this case, but depend on a different library or different other targets, so lib_b1, lib_b2. So if I open lib_a, right, it depends on lib_b. I can navigate to lib_b, and in principle, when this is run, it should output lib_a. That's what happened here before. Now what you can see here is this little widget. You select it, and you can load the other target that is defined for this source file called lib_a1. And, well, it marks it red because right now we don't automatically update the dependencies of the target. So I can also load the dependency here from the unloaded target. And now it's fixed again. So this is maybe not the most obvious use of this, but it's an example of how this functionality works. So it should work. Maybe I'll make a example project that does this specifically for Scala sometime, and the Scala cross-compilation. Because, this BSP plugin we made now should, in principle, work very similarly, not just for Bazel, but also for SBT or Buck2 if somebody at Facebook Meta implements a BSP server or other BSP-enabled build tools. Okay, that's all from me. Any more comments, questions? Okay. Yes?
The pictures that you had in your slides,
Thank you.